Assuming the strength of the Earth's magnetic field at this point is 5 times 10 to the power of negative 5 Tesla. Determine the magnitude and direction of the magnetic force on a 2-meter length of wire carrying a conventional current of 10 amp vertically up the exterior wall of one of the buildings. So if I want to write the formula, is F magnetic force equals to B times I times L times sine theta. B is showing magnitude of magnetic force, magnetic field, and it is shown in terms of Tesla. This one is magnetic force, and it has to be in terms of Newton. I is the electric current in terms of amp. L is length of wire in terms of meters. Sine theta. Theta is the angle between B and I. The angle between B and I. For example, if B and I are perpendicular, then theta will be 90. Sine 90 is going to be 1, so it is going to be maximum force. If it's 0, it's going to be sine 0, that's equal to 0, so make the force equals to 0. In this case, it says current is going vertically up, and it says Earth magnetic field. We know Earth magnetic field in north side is vertically down, so we have 180 degrees, so they are parallel to in two different directions. So it's gonna be 5 times 10 to the power of negative 5. I is 10 amps and 2 meters. Sine 180. We didn't need to even write these numbers here because we know sine 180 equals to 0. So there is no force in this situation.